Hello and welcome to Technology Today for September 1st, 2024. It's Season 1, Episode 25. Today, Merwatt and the Sentient AI from the future.
Good evening, ohmTown citizens, and welcome to Technology Today.
We're going to talk about moon dust to drinking water, high-definition moon atlas, spatter during 3D printing, mono lake organism, old metal learns new tricks, Iran targets space industry, mini brains for Alzheimer's treatment, making science fun to grasp ideas, catch and destroy forever chemicals, and combating coastal erosion simply. That and more, brought to you by ohmTown, ohmTown.com. Go over and become a citizen, and you can, basically engage in all of the other categories. There's 6 main categories, 50 channels, all of which have focus and focused news. That's where all of the news gets channeled into the various locations in ohmTown. Consider it kind of like a little town with a whole bunch of shops, and each one is a unique topic that you can peruse. Buy some tchotchkes. See you on the other side. So let's get into today's articles. The first article is over in Technology Today, how scientists are turning moon dust into drinking water. And if you want to turn the vacuum of links into a big pile of links, you can just type in !TT into the chat over at Twitch. It'll be in the show notes later. But yeah, that'll give you all, if you hit !TT, you'll get all of the show notes. And then if you hit ! and then show notes, it'll give you the syntax for all of the shows that we are doing and have done. The last episode that we have done, its show notes will be on command. So like TT, we'll bring up Technology Today. And if you want to get the podcast, then you do that, !pod. All right, folks, let's get into this article, how scientists are turning moon dust into drinking water. Chinese Academy of Sciences put this article together. It's posted over at SciTech Daily. So it says here the innovative process could potentially yield over 50 kilograms of water from a ton of solar soil, or lunar soil. Solar soil. Why I said solar soil. Lunar soil, paving the way for sustainable life and research stations on the moon. That's a ton of lunar soil to process, though.
It is.
Lunar water extraction is a section in this article where it says water plays a crucial role in human survival. Look, it's 6:42, no shit news. Thus attracting extensive research attention. Professor Zhongyang Wang's team at the Ningbo Institute of Materials Technology and Engineering, or NIMT, of the Chinese Academy of Sciences, CAS, so it's the NIMT CAS, has recently developed a new method of massive water production through reaction between lunar regolith and endogenous hydrogen. All right. So lunar regolith is the material that's up on the moon. It's basically like glass, and it's abrasive and gets everywhere. And if you're a Jedi, it can turn you into Darth Vader. Anyway, we used lunar regolith samples brought back by the Chang'e 5 mission in our study. So, bad bat written all over this. Trying to find a way to produce water on the moon. The study revealed that when the lunar regolith is heated above 1200 Kelvin with concave mirrors, 1 gram of molten lunar regolith can generate 51 to 76 milligrams of water. In other words, 1 ton of lunar regolith could produce more than 50 kilograms of water, which is equal to about 100 500 milliliter bottles of drinking water. So this would be enough drinking water for 50 people for one day. Now, this is going to turn it into sludge. The regolith is basically going to be completely dry in a big amalgam of regolith.
Right, and I'm assuming it can't be repeated because you've already pulled elements out of it.
All of the water would be gone. Yeah.
But you're using all that for, say, one day.
Right.
So, like, how much is available?
Oh, well, I mean, there's an entire moon worth of it, right? At least until you get down to the metal skin.
Yeah, but you might have a problem once you've kind of scraped all of it off.
God, there's a saying that I always say around the Sentient AI, and I really shouldn't say it because it has to do with test tubes and stuff floating at the top. Anyway, in addition to the lunar ilmenite, or FeTiO3, was found to contain the highest amount of solar wind implanted hydrogen among the 5 primary material or minerals in the lunar regolith, owing to its unique lattice structure with sub-nanometer tunnels. In situ heating experiments indicated that hydrogen in lunar materials is a substantial resource for producing water on the moon. Such water could be used both for drinking and irrigating plants. In addition to, it could be electrochemically decomposed back into hydrogen and oxygen, with hydrogen being used for energy and oxygen being, essential for breathing.
This is the second round of no kidding news.
No kidding news. That's right. Your code does not allow you to use any profanities.
Well, we're trying to be a family-friendly channel here.
The Sentient AI from the future is family-friendly, yes. Anyway, so yeah, basically you heat the regolith into a glassy mass and you get a bunch of water, but it's a one-time deal. And all right, let's keep moving. Next article's over in Technology Today. Discover the moon like never before. Scientists unveil world's first high-definition geologic atlas of the entire moon. It's over at Eureka Alert.
Does it spotlight all the regolith?
Yeah, really. This was scraped away by... so again, Chinese Academy of Sciences put this article together. It's over at scitechdaily.com. And I find this really awesome. I love the idea of a high-resolution geologic atlas of the entire moon. It says it's scaled at 1 to 2.5 million. So it was officially released on April 21st. The atlas, available in both Chinese and English, contains the geologic atlas of the lunar globe and the map quadrangles of the geologic atlas of the moon, including an explanatory manual. Now, what I just want is it high enough resolution that I can walk around on it with a VR headset on.
I don't know, that would be really neat.
It'd be fun to jog around the moon. Right?
Yeah, they should do that.
It includes the geologic map of the moon, a lithologic map of the moon, and the tectonic map of the moon. The map quadrangles of the geologic atlas of the moon includes 30 standard-sized quadrangles. Since the Apollo program in 1960, significant progress has been made in lunar exploration and scientific research. However, lunar geological research still uses lunar geological maps developed during the Apollo era, and I wonder how many times I have to say lunar geological.
I was hoping you could say quadrangle a few more times.
Oh yeah, quadrangle. So through studying and compiling elements such as lunar rocks, geological structures, and geological ages, the research team independently developed intellectual property in the form of technical specifications and standards for lunar geological mapping. That's number 8, I think. At any rate,
it's too bad we don't have a bingo card with only that term on there.
Yeah, just like all of the squares are lunar geological. So the set of atlases will support lunar scientific research, science education, as well as landing site selection, lunar resource exploration, trajectory planning for China's future lunar exploration projects, and it was supported by the 13th 5-year strategic planning program of IGCAS, the key frontier science research program at the Chinese Academy of Sciences, and the National Science and Technology Infrastructure Program of the Ministry of Science and Technology. Dun, dun, dun.
Well, this is really cool. I did not know they were basing everything off of a 1960s era map.
Yeah, that's kind of hilarious. I mean, why don't we just put a probe out there and it float around and take high resolution imaging? The team identified and marked 12,341 impact craters, 81 impact basins, 17 types of rocks, 14 types of structures, established a unified classification system for basin formation subclasses, and at the same time, the atlas also shows some special elements such as landing sites and special elevation points, and 2 aliens.
Yes, and I think they can use this for road maps, right? So it's like, avoid the crater.
GPS
like it'll
markers.
have a hazard marked on the driving map or something.
We don't even know where the moon really is.
That's true.
Moving on. Next article is over in Technology Today, Seeing the Invisible, How X-ray Reveals Spatter Behavior During 3D Printing. Research conducted by UCL researchers reveals and explains the links between vapor depression shape and spatter dynamics during LPBF under various industry-relevant processing conditions. So, International Journal of Extreme Manufacturing. I wonder.
Can you determine spatter behavior by running a 3D printer?
I'm not sure what they're actually detecting. So if it is predictable or anything like that, it just says how X-ray reveals spatter behavior during 3D printing. So it looks like they're doing X-ray imaging while they are doing the LPBF procedures, 3D printing. But it's scintillation. So they're looking to see if there's something subordinate to the primary deposition, and that can impact the quality,
the structure, the consistency. Yeah,
right. And so the work reported in International Journal of Extreme Manufacturing not only quantifies the spatter and spatter laser interactions, but also proposes strategies to minimize defects, thereby enhancing the surface quality of LPBF manufactured parts. So the spatter during LPBF can induce surface defects, impacting the fatigue performance of the fabricated components. It's one of the main concerns in industrial 3D printing applications, as says Chu Lun, Alex Lung, the corresponding author on the paper and associate professor of UCL Mechanical Engineering. I'm trying to see if there's anything else really.
If you don't have your design locked in, though, you might witness it on your own.
Well, I mean, if you... Wait, what? Say that again?
I'm joking about the spatter. Because if you set up your thing and it doesn't print as expected and it's going all over the room, you might be able to witness it without X-ray.
Yeah, really. It's like welding. And it is. It's just really small. So I guess you're sitting next to it while it's doing its job. It could sit there and spit little bits on you.
Right. I mean, you'd be able to see it on your shirt or something.
Yeah, that's such a subtle comment. You know, I'm sitting there going, wait, what? Well, why do I have these little metal bits on me? Damn it. So yeah, it says, because of its process, they're looking at how it's actually taking place, how it's forming, and increasing the quality is one of the objectives. So it says spatter may undergo oxidation, which lowers the recyclability and reusability of powder. Because when you get the part out of a laser sintering bin, you dust off all of the stuff. And if it's oxidized, then it's not going to fuse properly. And then a follow-on part and you don't want to keep dumping, gallons of this stuff out. So experiments were performed using a bespoke AM machine called the quad laser in situ and operando. Wow, operando process replicator, the quad isoper, the hopper, or the whopper from war games. Comprises 4 lasers and the industrial scan head system combined with a custom built environmental chamber filled with argon shielding gas. That's basically to stop anything from oxidizing while it's fusing. Using an in situ high speed synchrotron X-ray, both spatter and melt pool dynamics during LPBF can be captured at exceptional spatial and temporal resolution. The in situ experiments were carried out at the European Synchrotron Radiation Facility, so in mom's basement.
Absolutely. Repeatable by the average consumer.
Yeah, definitely. Yep. So the substrate with a 1 millimeter through thickness and 15 millimeter height is mounted in the chamber, onto which a thin layer of the powder is automatically deposited, and then it's fused together, and they monitored for spatter and the melt pool dynamics. And then from there, the further research is how to utilize that data to limit the spatter, stop the oxidation process, which may occur even inside an argon shield if it causes some chemical reaction and oxygen is produced but doesn't actually get out because the argon shielding. It could cause oxidation on something subordinate and trapped, but I don't do this, so that's conjecture. But let's keep on going. This is interesting. The next article is over in Technology Today. Mysterious new organism found in Mono Lake could rewrite the history of life. Or if you've been diving in Mono Lake and found this new organism, you could be history. Berkeley scientists have discovered a new choanoflagellate species in Mono Lake that forms multicellular colonies and hosts a microbiome, offering new perspectives on the evolution of multicellular organisms. It's angry, it's poisonous, and it is in the waters of the eastern Sierra Nevada Mono Lake. And by it's angry, it's poisonous, it's a salty, arsenic, and cyanide-laced water. So whatever it is that's living in there, yeah.
So don't jump in there for a swim.
Yeah, that's why I said your history if you're swimming around in Mono Lake. So this is what it looks like, apparently. It's a 3D reconstruction of a spherical colony of 70 choanoflagellates from the newly named species Baroeca monosierra, discovered in Mono Lake. But it's alive in this, so wow, that's pretty wild. The salty...
Okay, but that's worse, right? Because then it exists in extreme environments.
Mm-hmm. Aside from the abundant brine shrimp and black clouds of alkali flies, very few organisms live here. Alkali flies. Why does that sound like something you'd find on some strange planet?
It absolutely does.
Wow.
Sounds like a horror movie.
So the organism is a choanoflagellate, a microscopic single-cell form of life that can divide and develop into multicellular colonies in a way that's similar to how animal embryos form. It's not a type of animal, however. It's a member of a sister group to all animals. As animals' closest living relative, the choanoflagellate is a crucial model for the leap from one-celled to multicellular life. Surprisingly, it harbors its own microbiome, making it the first choanoflagellate known to establish a stable physical relationship with bacteria, instead of solely eating them. That's right. As such, one of the most simplest organisms known to have a microbiome. What a trip. So what you're seeing in the picture, the cyan indicates DNA, a donut-shaped DNA of the choanoflagellate cells, and a cloud of bacteria DNA inside the colony. While flagella are white and microscopic hairs, the villi, these little things, on each cell are red. So interesting. So inside here, it's creating a little environment.
It looks like it.
So, typically visible only through a microscope, choanoflagellates are often ignored by aquatic biologists who instead focus on macroscopic animals, photosynthetic algae, or bacteria. But their biology and lifestyle can give insight into creatures that existed in the oceans before animals evolved and that eventually gave rise to animals. This species in particular could shed light on the origin of interactions between animals and bacteria that led to the human microbiome. So if they did it, did they come before or after humans?
I mean, it looks like before, but we may not know.
This actually may have led to, humans.
I mean, this is a pretty significant discovery because of that.
Yep. And all of this information, the research and the discovery was published in a journal called Bio. It's just one M. Bio. So they actually end up talking about it more, but I'll let y'all go over and check it all out. It's pretty interesting, though. Huge surprise, just fascinating. No one had ever described a choanoflagellate as a stable physical interaction with bacteria. In the prior studies, they found choanos responded to small bacterial molecules that were floating through the water. So they were eating the bacteria, but none of them were actually just creating potentially a symbiosis, or in this case, a microbiome. Kind of makes it sound like they're farming the bacteria, right?
Yeah, this
like
really
it.
Sounds kind of
like that.
Terrifying.
So they say much of this is speculation. Future experiments should uncover how the bacteria interact with the choanoflagellates. So they don't even know. They just know that it was there. Past work in the lab has already shown that bacteria act like an aphrodisiac to stimulate mating in coagulates. Choanoflagellates, actually, is what it's called. And that bacteria can stimulate single-celled choanos to aggregate into colonies. So wherever bacteria goes, so too choanos go.
Right, so watch out if you have a concentration of bacteria.
And you're near an alkali lake.
Right.
Let's keep going. The next article is over. I should just go. Moving on. Technology Today is where the next article is. Caltech researchers teach in old metal new tricks. They've discovered a method to recycle a widely used reagent in synthetic chemistry reactions. Samarium, a metallic element, plays a crucial role as a chemical reagent in synthesizing molecules that could pave the way for new pharmaceuticals, and it was first discovered in a Russian mine in 1879 and was named after the mineral samarskite. Where does that fall on the periodic table? Let's see here.
Let me see.
Okay, so scaling up this versatile reagent to quantities large enough to be used in industrial settings has proved challenging. The reagent
it's atomic number 62.
Samarium?
Never heard of it, and it's from the year 1879.
So, well, it's no secret, but my memory does not pull that out of any
It's on that section that shows up, I think, at the bottom.
Okay. We'll get there. So the reagent is air sensitive, so you often have to prepare the solution fresh right before the reaction, or you do it in an area that it doesn't react in. If you use argon for welding and CO2 to prevent oxygen from infiltrating something that is oxygen reactive, why not do this so that you can use it more freely and make it shelf stable? So, and we often have to use large amounts of it, even in small reactions. It's not practical for running industrial scale reactions. Well, naturally. So you got to do whatever it is that protects it. Interesting. I'm really curious what this is all used for. So their solution allows the samarium diiodide reagent to essentially recycle itself for repeated use in a single reaction, which means large amounts of solvents and fresh preparations are no longer needed. They've discovered a way of solving it.
I mean,
Samarium,
that's something big in and of itself, right? Because they're not resource constrained.
yeah. And I'm not sure how often it can recycle itself.
Right.
But like usually with a reagent, there isn't a reduction because once you stop the reaction and you pull whatever it is you've been reacting to out, you can put more in and it reacts some more. So the samarium reagent has been limited to lab use due to pesky samarium oxygen bond that forms during the reactions and renders the chemical inactive. So how are they solving that? Now I want to know what. So in other words, the oxygen bonds lead to the dead end. It's like a samarium reagent becomes lazy, sitting on a couch and doesn't want to do. I'm right here. Why are I'm talking about this thing? What? Anyway, Boyd says that she and her colleagues at the Peters lab were interested in working with the Reisman lab because their research studies in nitrogen fixation involve the samarium iodide reagent or agent. Nitrogen fixation is the process in which a gaseous nitrogen from our atmosphere is converted to compounds such as ammonia that are essential for plants and the people who eat the plants. This process can be done naturally by bacteria and artificially through chemical reactions. So I guess they used nitrogen, converted it to ammonia. We use the samarium reagent in our lab to study these reactions, but it would be impossible to scale this up. Through conversations with the Reisman group, which specializes in synthetic organic chemistry, they joined forces. That doesn't actually resolve what I'm trying to find out.
No, but I like this. I mean, I like seeing in science how this happens, right? Across
Multiple
institutions or across countries.
Different fields, everything. Yeah. But that means they know what's going on in such a broad spectrum that they've found an answer in an area that is a tangent to theirs.
Right.
Reductive samarium catalysis. Enabled by, it says SM3. I think it's SM3. I'm not sure what that syntax is there. Alkazide protonalysis. Or protonalysis. Sorry, there's a thing. You have to do the right inflection on the right syllable.
Oh, exactly. Otherwise, you can't make it through the word.
Anyway, and I didn't want to give up. Okay, let's keep moving. The next article is over in Reality Hacker. Notorious Iranian hackers have been targeting the space industry with a new backdoor, and in addition to the long-standing password spraying attacks, which is basically just trying to hack into anything, APT-33 has developed